Welcome! In this video, Andrew KC3 HPS talks to us about digital mobile radios and repeaters.
So a little bit about just basics of DMR. Most people, when they hear DMR, digital mobile radio, it's generally associated with Motorola. Motorola really made the big commercial push, but it's actually an open standard by the European Telecommunication Standards Institute. Motorola and their Moto Turbo line really for years was kind of all the DMR gear. That's changed a lot lately as other manufacturers like Hytera come out, but there's really nothing Motorola specific about it. You can see the radio I've got here is a cheap Chinese one that's completely interoperable with most of the amateur use. Generally used on UHF, VHF bands. The standard itself supports, I didn't want to say 66 to 960 megahertz, but that goes way outside the amateur bands. DMR is really a commercial standard. It wasn't designed with amateur use in mind, unlike D-Star or some of the other modes out there. So you'll see when we kind of go through this, there's a lot of stuff that is a little bit weird for amateur use. There are a lot of things that have to operate a little bit differently because there were things that weren't really designed with that use case in mind. If there was kind of a decision to be made, it almost always got made on what's good for commercial use, because that's what was going to make the money. There are three main kind of types of DMR, and they're referred to as tiers. They aren't really types in that they're separate from each other, but they're kind of operating capacities. Tier 1 is just normal simplex mode, radio to radio. Tier 2 is repeater mode, talking to another device. There are some significant differences in how those guys communicate and what gets used when we talk about talk groups and other features later. Tier 3 is trunking. I'm not going to talk about trunking at all because it isn't used in amateur use at all. Requires a whole lot of very expensive licenses, and the benefits really aren't there. There's also a fair amount of proprietary stuff there that tends to, nobody's really even sure if you'd be able to run Tier 3 trunking on amateur use because of that kind of ban against encryption and some other things. So hopefully this shows up. So this is just kind of a graph. One of the big things I wanted to show about DMR, and one of the advantages, is kind of spectral efficiency. If you imagine this as a waterfall chart that I kind of turned on its side, over here is how wide each band would be required for one channel, and over here is time. So you think normal FM wideband, the kind of stuff we use in the repeater, somewhere around, what, 20, 25 kilohertz wide. FM narrowband, somewhere around 10 to 13 kilohertz, I want to say. D-Star, and I do this for comparison, uses 6.5 or 6.25 kilohertz, so it's pretty narrow. DMR kind of does things a little bit differently. So every one of these guys is one channel, right? There's one conversation going on at a time. When you tune in to your FM wideband or the 146955 repeater, that's one audio signal that's going through. Same with FM narrowband, same with D-Star for the most part. DMR actually uses TDMA, time division multiple access, or multiplex access, sorry. So what it's doing is, and you can't quite see this here very well, it divides everything up into two separate time slots, and those time slots are 30 milliseconds long. And there are two conversations going on here effectively. The blue ones we call slot 1, the orange ones we call slot 2. And it basically allows two completely separate, independent conversations at the same time. Why'd they do that when they could have just do what D-Star did and go down to 6.25, just take it in half? Part of that was because the FCC is really good at giving out 12.5 kilohertz commercial licenses. They aren't really good at going down to half. Then they'd have to figure out what channels can go next to each other, and you need a different type of license. It was much easier to get an existing 12.5 kilohertz license and just apply it here and have the added benefit of being able to do two channels at once. Another really big advantage of this is power efficiency. right? So now I can have spectral efficiency in my 12.5. I'm having twice as much conversations as I can in my FM narrowband, but really I can duty cycle my transmitter and my receiver. I don't need to be, if I only want to listen to slot 1, or say I only want to listen to slot 2, I only have to turn my radio on half the time. And you'll see that DMR radios have very, very tight controls on their transmitter, right? If you key down a PTT on an HT, right, normally you just expect the carriers there the whole time. You do the same thing on a DMR radio, and really it's like there's a little man inside the HT going like this 30 times a second. But you end up getting a fair amount of power efficiency. They say about 40% improvement in power efficiency because they don't have to transmit quite as much. So each one of these blocks here, these 30 millisecond segments, actually has 60 milliseconds worth of voice going in there. How do they do that? Well, there's a codec called AMBE+2. So a codec is just a way of taking audio, voice in this case, and encoding it into digital packets, right? Taking that analog waveform and putting it into digital information. Technically, AMBE+2, it's also pronounced AMBER a lot of the time, isn't part of the DMR spec. It wasn't specified by ETSI. However, it was adopted. It's a AMBE codecs are used in a lot of other digital modes as well. It kind of ran with it, and everybody uses the same thing for interoperability. There is an open source codec alternative to it called Codec 2, but that hasn't really gotten a lot of adoption yet. It's actually very closely related to the codec used by D-Star, which is AMBE, but it has a lot of improvements in forward error correction. It does have a little bit of that digital sound to it, but in terms of audio quality, it's generally a lot better than D-Star is, a lot less robotic. The codec is proprietary. You have to pay a licensing fee to use it, and it's only available in hardware. Every DMR radio, every D-Star radio as well, has a chip, a physical chip that decodes that signal and turns it into something usable, or encodes it if they're transmitting. That means that it's pretty much impossible to buy or build a DMR radio without having one of those chips. There are some arguments that since it's a proprietary codec, it's not open, that constitutes encryption. The FCC has pretty much said, yeah, that's cool in the US. The French equivalent actually banned D-Star in 2010, I want to say, saying that no, that wasn't cool, that constituted encryption, it isn't open, you're not allowed to use it on amateur bands.
Is that still the case, Andrew?
For D-Star, I am not sure. I was trying to find out. I couldn't find any decision that reversed that previous one from 2010. However, I know I've pulled up the D-Star map and definitely seen people transmitting in France, so.
That's different than regulations.
Yeah. So this is a totally unscientific graph. This was originally kind of the idea for this was taken from some Vertex standard slides, but they were heavily propagandized towards DMR, so I adjusted it a little bit to hopefully reflect reality a little bit more. So, if you take audio quality on this axis and signal strength, and I realize this is kind of reversed, but kind of as you're going further away, weaker. One of the really, really big advantages to DMR is that forward error correction, right? Having enough bits in the codec that, if a couple of them get flipped in transit, things that you would normally hear as, say, static on an FM audio signal, that it can correct them, and instead of getting a chirp or buzz or nastiness, whatever, you come out with relatively clean audio. The idea is that once you start getting out to a point where an FM signal, which is in the green, would normally start degrading as things go away, DMR stays pretty consistent, right? Some errors get introduced here, but up until the limit where it's not able to correct those packets anymore, it still sounds really, really consistent. And then things tend to drop off really quick and you don't hear anything. What's up?
What's the price you're paying for that signal strength? Is there a less audio quality in general, or what?
Well, so it isn't technically signal strength, right? I mean, it's effective intelligibility. Part of it is up here. I would say that analog FM generally sounds better in a really strong signal, right? And there are definitely places here where an FM signal would be able to get through weak, where the DMR just totally can't decode. Now, if you kind of draw an imaginary line through here, somewhere there is a point where something's intelligible or it's not, right? You can copy or you can't. You know, if it's down here in the really weak signal area, if you're able to interpret a really weak FM signal and still hear and hear, then analog FM actually has effectively more range than DMR does. If it's up here, then DMR has a much better effective range than analog FM does. A strong DMR signal is never going to sound as good as a really strong analog FM signal. This is one of those things that was really, you can see the commercial influence here, right? Most of the time, if you are buying a system of radios, say for your hotel, to talk to your staff and your security people and whatever, the fact that this sounds slightly better, you probably don't care at all, right? You just want to know that your people can hear you and copy stuff. In which case, as long as this line stays in that intelligible zone longer, that's all you care about. As amateurs, obviously, we spend a lot more time with radios. We tend to care about them a lot more than a guy that just kind of walks around and uses it as a piece of equipment in his job. So there's a lot of very subjective stuff going on here. That's why I said there's no scale. This is not a scientific measurement. I do have a version which claims to be scientifically measured, and I don't trust it at all. But in general, there are definitely areas where you can hear DMR coming through relatively clearly, where an FM signal wouldn't in some things. Again, that intelligible line, that invisible line, is going to depend a lot on your conditions too. Are you indoors? Are you outdoors? What's in the way? But in a lot of circumstances, DMR definitely outperforms the analog FM signals.
There are a couple of systems that run an algorithm on the signal at the repeater or central and slightly degrade the signal as a warning when you're approaching the falling off the cliff limit. The Air Force is using one, for instance. They don't want their security police guy to be saying, alert on pad 3, and find he's just gone. He's no longer in touch with the rest.
There are some DMR radios too. I'll show an example of this a little later. That will actually give you a report of what your signal loss is in terms of how much correction it's doing, so you kind of know, and maybe it'll give an audible tone, good connection, bad connection. But there are also a fair number of systems which will take an analog signal and do post-processing to try to remove noise as well. So as soon as you start dumping in more technology, that can go either way.
These times, sometimes they'll say packet loss or something, P loss.
Yeah,
something like that.
I think on mine there's like a threshold that gets passed where it'll accept some gracefully, but when you totally start sounding like a robot, then
It'll shut you down completely, but you lose a couple of syllables.
So a little bit more into kind of the nitty-gritties of how DMR works. So every DMR radio has a 7-digit identifier that uniquely identifies that guy. So why a 7-digit identifier? Why not call signs? Well, because those guys at the hotel don't have amateur radio call signs. It's a commercial standard. For amateur use, however, generally that ID is linked to an existing FCC or whatever international body call sign. Those 7 digits are actually kind of significant. The first 4 are a regional code. So this actually here is my DMR ID. 3142 is the regional code for Maryland. So everybody who registers one in Maryland, your number will start with 3142. 255 is just a sequential number. I was the 255th guy to register with this network in Maryland. The next guy who registers in Maryland will be 256.
You can have more than 1,000 in a state.
So there is technically the ability to go to 10-digit IDs. That's kind of being rolled out fairly slowly, but a lot of equipment is kind of being updated to support that. A lot of the back-end infrastructure really has to kind of work to get to that point.
Wow.
And again, that's 1,000 users in Maryland, so other region. The other thing they probably do is, start split up into a Maryland B, and then, start.
Like we did there.
Right.
I have a question.
Shoot.
You just lent your HT to someone else.
They're you. So it is very important that if you have a radio, you go and you reprogram that ID. The other thing is that if you buy a radio off the shelf, you have to program your ID into that radio. Generally, it's going to come with like a default of 0, and most repeaters are just going to bounce you. Most radios do not allow that ID to be entered from the actual panel itself. So if you buy any commercial one, Hytera or Motorola, you will absolutely need a programming cable and their programming software, and both Motorola and Hytera charge for that. Some of the more amateur-oriented radios, Connect Systems, and if you use the modified firmware on this guy, do allow you to do it from it.
But you've lent me your radio, and I use my call sign. Your radio still has your call sign in it. Is that a problem with the operation?
Yes, it is. Well, so it'll work.
It'll work, but it might cause consternation for somebody that's monitoring the IDs.
Yes, and I will show you it is very easy and encouraged to monitor those IDs. In that case, they will show up on all the status monitoring stuff as you. In fact, depending on the radio, your call sign may appear on anyone who hears your signal screen. However, phonetically, they will hear you identify with yours.
Same thing with these stuff. I mean, they're streaming the programmed ID if somebody picks up or steals your radio.
Yeah. Every packet gets identified with that. What's up, Jameson?
This may not be possible, but what happens if two radios are programmed with the same ID key up at the same time?
It is definitely possible. On a good day, the repeaters get really confused. On a bad day, things can get messed up in terms of routing, and depending on if you guys are in 2 different locations and the servers are trying to figure out where the heck this person actually is, repeaters may get flooded with duplicate traffic. Every system I know of has a way to handle that gracefully, and generally it's to ignore both of you. But it's not something I would try, if you can avoid it. So every transmission that you make is tagged with that ID, like I said, and the list of call signs locations is totally public. You can go, you can download a CSV file of every, oh, I'm sorry, I missed one.
What if I have 2 radios?
So generally, if you have 2 radios, and you're not planning on using them both simultaneously, they say just use the same ID. There are ways of declaring like a sub number, and that's one of the things that 10-digit IDs help with, where if you have that capability, they say, well, use your number and then add a 1 on the end, or add a 2 on the end, or something like that. That's kind of the preferred method of doing it, rather than going out and trying to register 2 separate IDs. So that ID, that list is public, and there are some interesting things that you can do with that, which I'll get into a little bit later. So all amateurs, there are multiple DMR networks, which I'll get into in a little bit, but pretty much all amateur IDs are managed by one organization, which is called DMR Mark. It's made up of Motorola repeaters. But they continue to manage the IDs for everyone, even if you don't intend to use them. IDs are totally free. You don't need a radio to register. All you need is a call sign. It does take some time, though. It's done entirely by volunteers, and you tend to go register from the main site, and then they go forward your information to whoever's in charge of the region that you're a part of. So it tends to take up to 3 days or so. If you have any interest in DMR, I highly encourage you to go to www.dmr-mark.net and register for your call sign for an ID. Totally free, and again, that ID has to be programmed into your radio, like we mentioned So, starting, the what really big benefit, at least for amateur use, or the one thing that everybody tends to think of when they go talk about DMR is repeater linking. And this is a tier 2 feature, right? This doesn't exist if you're just trying to go radio to radio. It's a lot like D-Star linking with a couple different differences. But just kind of going from a conceptual point of view, when you have an analog FM repeater, right? It's generally a frequency with an offset, and then maybe a PL tone. You need to access that guy. When you link analog repeaters together, it tends to be the exception rather than the rule, right? There are many different ways of doing that linking. The constellation we have for Mark, right, uses different sites and they have an RF backhaul, but they're all on the same frequency and they use a voter to try to figure out who gets to talk. The WA4TFZ system down in Virginia operates totally differently. They have 4 different sites, but they use 4 different frequencies and you have to manually tune into one of them. There are a lot of different ways of doing it, but there isn't like one true standard for the most part. There's no real formal way of linking analog repeaters across the board. DMR linking is pretty formalized, and the back end is absolutely almost always over TCP/IP, right? Just over the internet. You go into a normal DMR repeater, and it has an Ethernet cable. You configure it for network access, and he communicates upwards to some kind of master. Now, how that actually works, the protocols that it uses, those tend to vary a little bit from repeater to repeater. Hytera does it totally differently than Motorola does. So conceptually, they all happen through the same route. If you're using a radio, you don't necessarily have to know how any of that stuff goes on. But from network to network, there are some differences. If anybody's interested in those differences, I can kind of get into that a little bit later, but that could run a whole gamut of an hour by itself. So the first step kind of in thinking about DMR linking and how it works is to really separate the conversation from the repeater, right? When I dial into 146.955, I'm talking on this frequency, and that's the one conversation going on in that repeater, right? If I go to another repeater, generally that's the conversation. Those conversations are intrinsically linked to those repeaters. For DMR, it's not necessarily true. The conversation is actually a totally separate concept than the repeater itself, and can kind of move from repeater to repeater or be delivered from repeater to repeater.
Like a cellular network.
Like a what?
Like a cell network.
In a way, yeah. It's kind of like if I have, I'm trying to think of a good example of it. I mean, if I think, the number one thing I think of is like a chat room or something like that, where you have a channel that you join, and you can access that from any point. Cell phones are pretty similar in that I can bring my phone from access point to access point. So yeah, I guess in a good way. So that separating that conversation out from the repeater is really the core concept behind that tier 2, DMR tier 2. That doesn't exist on the simplex mode because the conversation there is entirely the frequency, right? You're dialing in and you're talking to people kind of in one group. So that conversation on DMR is referred to as a talk group. So whenever you transmit in tier 2, all your transmissions are coded with a talk group, and that talk group is identified by a number. That number I think it's a 16-bit up to 65,535. That could be a little more, but it's a number. It's generally somewhere around 2 to 5 digits. Repeaters are configured to accept different talk groups and to handle different talk groups. And those talk groups are generally kind of harvested from other repeaters or other master servers, depending on how those links happen. In amateur use, most of the talk groups are organized by area or a language. Generally, they're not organized by like topic where, you know, somebody wants to talk about cars or something. It's almost always an area. And talk groups can either be static or dynamic. Static means that that repeater is always going to be getting the content to that talk group. A dynamic one means that it's only going to be getting content for that talk group when it thinks that somebody's trying to listen to it. These are also referred to as PTT talk groups, because the way you generally tell the repeater, hey, I want to listen to, say, the Florida State channel, is to try to transmit for a second, just key up on Florida State. What's up?
So you've been using this for a few months. I was just curious as to your experience locally. I mean, is there local DMR repeaters, and how's that going?
So there is a local DMR repeater in Ashton, Maryland. It's part of the K4USD network, which is actually part of the DMR Mark stuff. There's also another one in Damascus, Maryland, which I can almost hit from Germantown, but not quite.
So it's working out pretty well.
Yeah, it's been working out extremely well. Anyone who's talked to me while I'm at work knows that the building where VisArts is, right next to the library, is like an absolute RF black hole. And from the 4th floor, I can barely hit the repeater going at 5, sometimes 10 watts. I can hit the Ashton repeater reliably to the point where I have no real loss in signal quality at all. Whereas I know I've had a couple conversations with you where I've literally been standing on a chair with a radio like this, trying to get enough signal to get the repeater to kick. But I've had really good experience with it. I've been able to talk to people, you know, worldwide. I had a conversation with a guy from Israel at one point when they were doing the Jamboree on the air. So personally, I'm a big fan. If I wasn't, I probably wouldn't be up here talking about it. What's up?
So these talk groups, it says repeaters can handle multiple, or talk groups are configured for, so they can handle multiple talk groups.
Mm-hmm.
And if they do, are they done simultaneously, or they have to share the?
So they have to share the time slots,
Okay.
and that's something which I'll bring up again a little bit later. But so you can have multiple talk groups linked to the same repeater at the same time, but depending on how the repeater is configured, generally there's a priority list for who wins. And if somebody is yammering on a talk group that's configured as a static, you're going to get it.
Okay.
There are, especially for wide area talk groups, and ones that are commonly linked to full-time, and I'll show an example of that on the next one. Don't carry on long rag chews on there. You will be transmitting on literally every repeater in that network in whatever that area is. And it's really common for people to get the radio for the first time. You know, they go over to like North America or something, and they have their first conversation, and about 15 minutes in, somebody's like, hey, can you guys move to another talk group? Maybe there are other people who would really like to use this. I'm over here in like Scotland or something, and you're totally blowing us up. But that's really one of the advantages for those dynamic talk groups as well, and one of the reasons that they exist. There are some that are referred to as tactical channels or user-accessible channels, where if you want to switch over to one of those guys, you got both key up, and it's kind of like a slightly more private version. The repeater that he's on links up to that group, the repeater that you're on links up to that one, and everyone else who's not linked to that one doesn't necessarily. And they have the ability to link in and do it. It's not private, like, oh my God, I want to make sure nobody else can hear us. It is amateur radio after all. You know, it's definitely not forced on anybody. Generally, when you do activate one of those dynamic groups, there's some kind of timeout involved with it, maybe 5 minutes, 10 minutes, something like that. And there are some consequences to that. I'll get into a little bit. I'm not sure. Hopefully this is readable, or at least somewhat readable. This is the list of talk groups that's offered by the K4USD repeater, or really the network that it's a part of. And you can see here, you know, generally, again, most of them are regional or, you know, by state, something like that. these are the talk group IDs, and these are the time slots that they're offered on specifically on this repeater. These could be linked to any time slot on a different repeater. There are some setups, including Brandmeister, that allow you to link any talk group to any time slot you want. FPTT is whether it's full-time or push-to-talk. For this particular one, generally any region that you're a part of is full-time, and anything else is push-to-talk. When there was the hurricane going up to the coast a couple months ago, everybody was linked into Florida and all the areas around the coast trying to hear what was going on. So generally, all these are available to you. They just may not be turned on by default.
That's the time slot is like a channel, right?
Well, so the times, kind of, it's a sub-channel, right? When I was talking before.
That goes to like.
Yeah, and it's generally done by the radio configuration. And generally, you're only listening to one time slot at a time, right? That's what the radio is duty cycling to save you power. So I don't know of any system that allows you to listen to both time slots simultaneously. I'm sure they're out there, but they aren't in wide use, and I definitely can't afford them. So just kind of an example of how these guys are set up. So really normally when we think of a channel, right, it's again that kind of frequency, the PL tone, whatever you need to join a conversation on a repeater. DMRs their kind of version of channels are a little bit more complicated, right? A DMR channel links one conversation, one talk group to one repeater. So in addition to the stuff you need to to actually find out where the repeater is, the frequency, the offset, you need to know which time slot you want to talk on, 1 or 2. You need the talk group number, and you need the color code. The color code is kind of the equivalent of the DMR PL tone. It has to be set up to what the repeater is, so it'll accept your signal. Now, strangely enough, the color codes are an integer value between 0 and 15. So yeah, thanks ETSI, color codes aren't colors at all. That makes total sense. They are mandatory though. They are encoded on every packet. 99% of the time for amateur use, you're going to see it set up as color code 1. There really isn't a lot of, normally with PL tones, the common use is to try to avoid accidental transmissions, right? You get a little bit of noise and you don't want it to key off. Because this is all digitally encoded, the chances that you're going to have a packet that has the correct checksum and forward error correction, everything else is pretty much nil. So they're generally only used for privacy. So, when a lot of stuff going on there, when you press PTT, a lot of things are going to happen, right? The radio that you have is going to send out a packet to the repeater, and that packet is going to be encoded with your user ID, that 7-digit number, the destination talk group, the color code. The repeater is actually going to try to send packets back to your radio, setting whether or not you're actually allowed to transmit. And there are all sorts of reasons you may not be allowed to transmit. Your user ID could be blacklisted. 0 is almost always blacklisted because that's the one that most of the radios come with, and if you don't program in your ID, they don't really want to hear from you. You could be trying to talk to a talk group that's totally unsupported by that repeater, or just a number that you made up. You could have a color code mismatch. You could have a bad connection, and it's so flaky it can't understand what you're saying. There could be another user transmitting at the time, in which case it's going to give you a deny. Normally, the radio will probably give you a tone at the end of your transmission, either saying it's good, or it may cut you off shortly after you press down the button, giving you a tone saying, no, not permitted, you're doing something wrong. When you set up a DMR radio for the first time, you're probably going to hear that tone a lot if you aren't intimately familiar with all the settings. So, assuming the repeater likes what you're saying, it's going to go and try to figure out which talk group you talk to. Assuming you didn't get the deny tone, it's got to be one that it's configured to. So it's got to figure out, is this one that I have a normal stream coming from? Is this a static group? Or is this a dynamic group that I need to go talk to my master and figure out where I get that stream of data from? And then your transmission you start receiving audio for that talk group, and the transmission is going to be distributed to other repeaters who are listening on the same talk group back through that same channel up. And obviously the local repeater will send your packets out over RF to anyone using the local area there. So DMR networks, I mentioned these before. There are really three big ones. Actually, there are three main ones for amateur use, and two of them are big. DMR Mark was kind of, for a long time, was the only one, effectively. It uses the Motorola IP Site Connect protocol for linking. The side effect of this is that every single repeater there is actually has to be a branded Motorola repeater. That is a proprietary protocol. So, as I said before, how the linking works is pretty much standardized, but the actual implementation can be totally different from repeater to repeater, depending on the vendor. So that is the network that K4USD is a part of. So if you just were to grab a radio here, that's probably the network that you would be on. Because they use that proprietary Motorola protocol for linking, they don't support hotspots. I'll get into exactly what a hotspot is later, but just remember this is the only one that doesn't support hotspots. DMR Plus, that was kind of an offshoot that catered more towards Hytera repeaters. I was under the impression at one point that they were using Hytera's proprietary protocol, but that seems to have changed for a while. This used to be kind of the main alternative to DMR Mark. Its use has really dropped within the past couple of years. Still a fair number of supported repeaters in Europe, but very little coverage in the United States. Brandmeister. So this, a year ago, was a brand new network. Originally done by a bunch of German developers, has really grown at a really terrific rate in the last year. DMR Mark tends to be very conservative. They tend to use very insistent on using only Motorola equipment, and they're very tied to a lot of those proprietary standards. Brandmeister has a lot of their own software stack, where they have actually implemented different protocols from different vendors. So you can actually have a really good mix of repeaters. You may find a Motorola, one guy's on a Motorola, one guy's on a repeater, and one guy's on a hotspot that he's running off of a Raspberry Pi. They support a lot of homebrew efforts. So they provide the configurations, anyone can join it. If you have a DMR repeater, unfortunately, because they implement a lot of proprietary protocols, they have NDAs in place with Motorola and Hytera and others. They cannot open source their software. So they run a series of servers that the individual repeaters will connect to, but they can only say so much about how some of the stuff works under the hood. Other advantages of DMR, or cool things about it. So I said before, all of this stuff is linked up via TCP/IP connections, right? All these repeaters generally have a back end that are in a network. So every time someone transmits, and it has one of those 7-digit IDs in place, they can look that up in that giant database of users and figure out, what their call sign is, where their name was, where they're located. Every packet is set up with which talk group they're a part of. All of this information is available for pretty much every network on some kind of live streaming page. And I'm going to minimize this just for a second. And hopefully my network connection is still good. So this right here is live, who is on the K4USD network. Talking from New Jersey, his call sign is WA2MOL, he's in the tri-state area. These are the previous conversations we were going on. This was the duration of those transmissions. And if I'm really, really lucky, this page looks like it's, what the heck? Okay.
That's the time it was
oh,
like 5
I'm
o'clock
sorry.
this evening.
You guys aren't seeing what I'm seeing.
Okay.
This is set up as a second display, so this is what I'm seeing. So this is the live data, sorry. That was the screenshot in my PowerPoint. So if I'm really lucky, if I just key up this for a second, that went past really, really fast. But here, crap, I lost it.
Well, just do
It goes so fast. Well, the problem is if I do it again, same thing's going to happen. You need to pause it first. All right, I'm going to try it one more time real quick. And generally, all these networks are set up because keying up is kind of an important part of being able to link things. Transmissions under 1 second, they generally ignore the audio for those. Specifically, so you don't keep getting snippets of audio from people just trying to link up to a repeater. Let's try this again. There, Ashton, I saw it, and then it died again. All right, so my demos don't go nearly as smoothly as David's do. Sorry. Somewhere in here is one that says Ashton, Maryland, if I can get the silly thing to stop scrolling. So as you can see, there's a lot of activity going on in DMR. A lot of people using
Is this only one talk group you're seeing now?
This is every talk group on this network.
Oh.
So the talk groups are actually here. Talk 311, Bridge CC, so these are all talk groups. This is, and the reason it's scrolling so fast is this is literally everybody talking on this network of 500 repeaters across the United States.
Why is there two sections? Is there something particular about that?
Oh, I'm sorry, let me go back to that. These are the current these are the people that are actively transmitting right now. So you see these numbers are counting up. These are the people who are literally holding down PTT right now. This is history. So as soon as you stop keying, it goes from here down to here and then scrolls off before I can ever find it again. So this is actually ends up being pretty useful in a lot of cases. The big one is that, now I'm looking at something. The big one is, you know, this is, if you're used to contesting or something like that, you can tell where activity is going on at any point in time. It's like having your own built-in spotter network. If you want to talk to somebody or you want to try to find out when somebody was last active, you can look it up. All that information is kind of at your fingertips. So again, every network has this. Brandmeister does it. One of the other nice things is you can see the loss rate. Because these guys are able to do that error correction, they can see when you have bad packets. So this guy here is obviously having some problems. And you can see because he has a bunch of really short transmissions after each other, looks like he's probably breaking in between them. You know, everyone else here is doing pretty well in terms of loss rate. So it's also a really helpful diagnostic tool. When you set up the radio for the first time, you know, you can key up one of the not very often used groups, and the first thing people generally do is look at a page like this to see, am I actually making it through? Can they hear me? Are my packets going through? Hotspots. So I mentioned these before. So what happens if you don't have a DMI repeater? What happens if there isn't one nearby, and you know there's no one you can talk to? You aren't totally screwed. The good news is that so your radio is taking your voice and putting it into packets, and what a repeater does is it takes those packets across the air and then eventually routes them up to some other thing on the internet. Well, if you have a really low-powered transceiver and an internet connection, then you can effectively build your own like 10 milliwatt mini repeater. Turns out these work really, really well. If you are in an area that does not have any RF coverage, if you are in the black hole that is my office, you can plug in a hotspot connected to the network and talk to all the people who may be hooked up to a repeater. They may be hooked up to a hotspot as well. Most of them support DMR, D-Star, and C4FM. So the big thing about the hotspots is they don't actually understand what audio is at all. These guys generally just pass packets. Your radio is the one who has the codec installed, who's taking your voice and putting in digital information. And then these guys just pass the digital information out. You still need a DMR radio to be able to interface with these guys. So I will say that Generally, the other end of these guys has to be a network that supports a certain connection protocol called, it's generally referred to as Homebrew. Unfortunately, DMR Mark does not support that, Brandmeister, and DMR Plus 2. There are a bunch of different ones on the network. The DV4 Mini, I know a lot of people have used here in Mark for D-Star. Unfortunately, does not perform very well for DMR. There are some issues there with the software that Wireless Holdings is working on. Excuse me. The Shark RF OpenSpot is one that I've used a great deal and is incredibly reliable for both DMR, D-Star, and I've heard C4FM, although I've never actually used it before.
Can you say about the other hotspot, the third one? You didn't
Oh, so the DV Mega. So the DV Mega is a really popular kind of homebrew alternative, right? It's just a transceiver that will actually plug into the 40, I think it's a 40-pin connector,
Yeah.
On a Raspberry Pi. There's also a version of it that will connect to Bluetooth to do tethering via cellular phone. So if you're in an area where you have no coverage whatsoever, you don't have a residential internet connection, you can tether it to your phone and still talk over DMR. But that guy, I think, is used a lot by the Maryland D-Star group. I think they have their own image for that guy specifically for D-Star. But all three of these guys will do all three protocols. Pretty much for all of them, they're just, again, taking those packets, chunking them up, throwing them out the internet, and vice versa. So a couple kind of DMR things that are not, they're the kind of things that you think them through, they make sense, but are not immediately obvious when you kind of go for the first time. The first one was actually the one that you brought up. Airtime is a resource, right? And that airtime may not necessarily just be the airtime out of your local repeater. If you are talking on those full-time talk groups, you may be transmitting effectively over a very wide range. On full-time talk groups, try to keep discussions to a minimum, switch over to another one, another push-to-talk group so that you don't effectively spam everyone in that repeater network. Another kind of side effect of that push-to-talk behavior, you usually can't just listen to dynamic talk groups, right? One of the first things that happens is somebody goes in and they say, okay, I want to go listen to this talk group. And they configure the radio to do it, and they turn that to the channel, and then it sits there and nothing happens. If that's a push-to-talk group, the repeater that you're talking to probably doesn't know that you want the audio until you try to key up. So in DMR, if it's a push-to-talk group, it's kind of an active listening exercise, right? Tell the repeater what you want, and you'll eventually get the audio. There is generally a timeout. Like I said, maybe it's about 5 minutes, so you may be hearing somebody, and if you aren't actively talking to them, audio will probably cut out after a while. You just key it up. Another thing, so TDMA, that time slicing stuff that I talked about the first time, is really, really sensitive. When we're talking about transmissions that are 30 milliseconds, and then you need to unkey so that someone else can possibly transmit on that other time slot, because you guys are going back and forth if there are two people using the repeater at the same time. Any type of external equipment that may be trying to interface to the radio, like a linear amplifier, will probably totally screw with that. You put a linear amplifier on a TDMA radio, and unless it's incredibly sensitive about that, it's probably just going to kill both talk groups. And last one, beware Tier 1 or Slot 1 radios. This goes back to that, this is actually really related to that TDMA being sensitive. There are a couple manufacturers out there, Baofeng in particular, that have tried to get into DMR and produce what they call Slot 1 radios. These are radios that have a couple flaws where they cannot do that timing quite well, and when you transmit on them, they just wipe out both time slots. The Baofeng has one DMR radio. I would say avoid it at all costs. I'm normally actually a pretty big fan of Baofeng, aside from their spurious emissions problems. But that is a really good way to get your ID banned from local repeaters. Every repeater network has come out and said, do not use this on our network. Use it for simplex, we don't care, but don't put it near us. It constitutes a denial of service. What's up?
So with the TDMA thing, so when I key out, it's going to start getting in sync with the repeater or whatever that I'm talking to. So how does it kind of like, I mean, it's obviously timing is really critical, so how does it know when to start its like slots, like where the slots begin and end?
So I've wondered about that. And my understanding is there's some kind of beaconing that goes on so that it can kind of sync up. It's kind of listening first for something from the repeater and then syncs up. Don't quote me on that though.
But it has to do it every time you key up again, I guess, right?
I would assume so.
Yeah.
I would think it's the receiver's is time basing its time, it's clocking from what it's receiving. So it looks based on what it's receiving, it sees where the slots are, and that's how it knows where to try and attempt to
Right, but
transmit.
that implies that the repeater is transmitting
Right.
something periodically. It's not a continuous stream. I want to talk about, so I tried very hard not to talk about specific gear here, not to go into, how this particular radio works. And I do want to talk about this one though, the MD380. This is kind of significant, at least from my perspective, because it's really the radio that has commoditized DMR for amateur use. You look at most of the Motorola's out there, and you're going to expect to pay, in the $500 to $700 range, somewhere around there, before you pay for the cable, before you pay for the licensing fee to use the programming software, to put the ID into the radio, all that jazz. This was really the first DMR radio that was available for under $200 that was actually worth owning. Right now, it's the most common DMR radio for amateur use. You can pick one up for about $100 from Amazon.com. There is modified firmware available. There was actually a really good talk at ShmooCon 2016 by Travis Goodspeed about his project to decrypt the firmware and apply binary patches to it to add new features. One of the features includes the ability to edit that DMR ID directly from the keypad, which is, if you're loaning it out, really, really important. There are a couple other models. The MD390 is pretty much more of the same, but waterproof with the GPS. It's been rebranded as a bunch of other models. Like I said, the only reason I mention this is really the radio that has made DMR accessible to a lot of people.
You can do them all, you can do FM on that?
You can do FM on it, however, it is a single band. And almost all amateur use DMR is on UHF. It's incredibly rare for VHF. So I actually bought another one of these and gave it to David earlier.
Right.
So we now have a DMR radio available in the Mark Lending Library.
Right.
If anybody would like to grab it and play around with it. That is also specifically why I added this firmware. So if you go to the website, register your ID, you can go in there. It's already configured to talk to that K4USD network. So in theory, you just need the ID, pop it in, and you can be going.
So the radio is already configured.
It is already configured.
Okay,
How do you
so
pop in the ID? How do you put the ID in it?
It's through the menus. I'll show you.
On the radio?
Yeah, with
In
the,
this sense.
with the modified firmware, yes. You can go directly through this.
so what you're saying is to lend it to the next person, it makes sense for the previous person to sit down with the next person and program the next person's ID in it. Because if that doesn't happen, guess what happens? Everybody's going to be using one ID all the way around.
Absolutely.
So, which suggests if there's another call sign that the club owns, W3EXP. Maybe use that. I don't know.
We could register that guy as long as there's a license attached to it.
Yeah, there is. And
We could.
it's Montgomery Amateur Radio Club.
We could.
Talk to Jeff, the
Yeah, you have to talk to the
trustee.
trustee, licensed trustee about it.
Yeah, I got to talk to Jeff. Or
Is there such
or
a thing
person
as the
to person.
DMR dongle?
You just change the ID.
To the best of my knowledge, no.
That's what
So the DMR
Just thinking out
dongle,
loud.
and I assume you're referring to like the D-Star dongle, right?
Yeah, so you wouldn't need a radio.
Right, that guy's really just an ambi chip on a stick, effectively. I don't know of anybody who's produced that for Ambi 2. I do know, I shouldn't say that. I believe I know of at least one person who does something like that so you can interface with software-defined radio. I don't know of anyone who's actually come up with the software stack to be able to integrate that chip together with a receiver.
I think there'd be a big demand for that. I mean, if you're out of range of a repeater, you don't have a radio.
Oh yeah, potentially. So far, all the development effort really seems to be going towards the hotspots rather than the dongles.
So in other words, a hotspot is like a radio plus a dongle. A radio plus a hotspot equals a dongle.
Effectively, yeah, except you're actually using the mic on here instead of one of the
Oh, so what you're referring to as a dongle means you just use the computers like a
Computer
headset
alone,
and
yeah.
stuff. Okay,
Right.
gotcha.
The hotspots are really the equivalent of the, I think it's the DVAP
Yeah.
for D-Star.
Right. You referred to Ambi Plus 2. How's that different than Ambi 3000? D-Star uses Ambi 2020, which is kind of old. And Ambi 3000 is backwards compatible to Ambi 2020. Northwest Digital Radio sells a device called a Thumb DV, which is like the DV dongle, except it's $100. They use the Ambi 3000. So what's an Ambi Plus 2? A different chip?
That's my understanding. Now, I won't, again, don't quote me on that.
Okay.
That's the, Ambi Plus 2 is the identifier that I've always heard referred to, and it's even the one that I think it's on the side of the box. They specifically mention on the feature set of that radio. I'm not familiar with Ambi 3000, but I've also never heard the version that D-Star used referred to as Ambi 2020. It's entirely possible that Ambi 3000 is Ambi Plus 2, but I was under the impression they were not backwards compatible. So there are more codecs out there than I know about for sure. I can look into it and get back to you, but I'm not sure offhand, sorry.
A buddy of mine got a job, 40 hours a week, removing those codecs from some government cell phones and turning them in very carefully. Nobody knows about them except a certain element of the government.
Andrew, these codecs, earlier I thought you had said something about they change sometimes the codecs. Maybe I misunderstood it, but this is these chips that we put in our D-Star. Do they have a shelf life where we'd be required to plug in a newer version of the chip?
Not to the best of my knowledge. If that came to place, it would basically be a new version of the protocol, right? None of the previous equipment would be compatible. I mean, if they change the codec significantly, that would be the equivalent of why DMR can't talk to D-Star, right? You're effectively talking a different language.
And Motorola would be at the bottom of it.
Wouldn't surprise me. So there are a bunch of vendors that make DMR radios. Motorola, obviously, the Moto Turbo series is the one that's most well known. Connect Systems is another small manufacturer that is producing radios specifically for amateur use. A little bit more expensive than the Titeras, but they do have a lot of features built in. They were actually the first one to add the front panel programming of the DMR IDs. Hytera, another really successful in the commercial place manufacturer. Kenwood makes DMR radios, but they don't sell them in the United States. Vertex Standard, again, really big in the commercial space. I think they're owned by Yaesu. And Baofeng makes one DMR radio that I don't suggest anyone buys. So there's a lot of digital standards out there, right? DMR is just one of them, and it's a very successful one, and it's seeing a lot of use in amateur use. But I just kind of wanted to talk about the things that aren't DMR, because I'm sure everybody's seen at least a couple of these. So every one of these is totally incompatible with DMR for one reason or another. D-Star, right, ICOM's, well, really the Japanese amateur radio thing, but then adopted by ICOM, uses Ambi 6.2, 5 kilohertz, so totally incompatible. C4FM is Yaesu's, also uses Ambi Plus 2, I believe, not the Ambi. P25 is a standard that was originally done for public service and emergency use, I want to say. Has a lot of similarities to DMR from a design perspective, but it used frequency division multiplexing, so totally incompatible. NXDN, I don't know a heck of a lot about this. My understanding is used a lot by the rail industry. Same codec, but again, FDMA, so totally incompatible. And DPMR, it's another kind of niche European standard, but FDMA, totally incompatible. So these things are all totally not DMR. They're all kind of competing with DMR in one way or another. Some of them are more successful than others. So I realize I'm probably like way over time here. Sorry, but just kind of want to go over, so why be interested in DMR at all, right? Just a couple of the benefits. Spectral efficiency, being able to have those two conversations in the same 12.5 kilohertz time slot. Power efficiency, potentially up to 40% battery life. Intelligible audio with really poor connections. Times when, maybe FM would be scratchy and you wouldn't be able to understand someone, that forward air collection can help you get an understandable signal through. Repeater and hotspot linking, this is the big one for me, right? Being able to talk to somebody on the other side of the world with a 5-watt HT and technically only with a technician license. The amount of visibility you get with last heard, being able to tell who's talking, where, what's going on, and if you just want to kind of join in the conversation, go for it. Lower cost on a lot of those other digital modes. What I think D-Star right now, the cheapest way to get in if you're buying new is to buy an IC880H mobile, which is about $250 to $300. Like I said, new, out the door, $100, programming cable, everything included.
Oh, programming cable.
So that $100 from Amazon includes the programming?
Oh yeah, you can. That's the box right there. You can see it's got antennas and the charging thing and the software and everything you need to go.
So it's dropped $20 in 3 months. I mean, I'm not surprised.
It's actually gone up $2 since I originally said that it was under $100, and then the price went up by like $2. So now it's 101 or so.
What is your lowest or your weakest link in the chain? Because when you talk about repeater use and worldwide connectivity, does not depend on the infrastructure of the internet?
Absolutely, it totally does.
So,
and the way the amateur networks are set up, I would not recommend DMR, as a replacement for HF in an emergency situation, any stretch of the imagination, right? If you're in an actual emergency, I'm not going to say, oh yeah, use this. This totally works all the time. But it's another tool in the box.
no, it is,
right?
but I was just wondering, just how much impact the internet would have on this, that's all.
So the internet has, it depends on your connection, right? I tend to have a better network connection than most. So that is not the weakest point for me personally. But I'm talking to somebody who has a weak network connection, that can definitely be a significant factor.
If you happen to know, what's the minimum connection speed you would need to have where other people aren't going to be having trouble from your end?
So raw connection speed,
Yeah.
it's incredibly low. I'd say somewhere around, and I'm estimating here, but I'd say somewhere around 64 kilobit. Latency is way more important, right?
Okay.
If you have a 5 megabit satellite connection, you need not apply, right? The latency is going to be terrible, and you're not going to be able to understand anything. Or maybe you will be able to understand the conversation that happened like 5 minutes ago when you actually get the packets. So
It'll be entertaining if nothing else.
it's all about quality, and it's all about that generally trying, as long as you have a reliable connection, it can get pretty slow. When we're talking about the amount of encoding going on there, it gets it down to a very, very convenient data stream.
Well, there are several people here who've done a lot of experimentation in both mesh network and Part 15 linking across pretty good distances. Could you link a pair of repeaters that way that was using that protocol and still have them work with each other?
Absolutely.
Okay.
As long as the connection stays up and is relatively reliable, right?
Yeah.
There are a lot of cases where if you're doing something like a TCP/IP connection, your connection drops out for 10 milliseconds, a retry goes out, and tries again. When you're talking about a UDP data stream, then the packets are gone, and you've already passed that. There will be an audible gap.
So that's an important point. Thank you for reading my mind. So in other words, let's keep it simple.
Sure.
We can have two repeaters connected with a local area network, a long Ethernet cable,
Sure.
and without any connection to the internet with a capital I. That will work?
Absolutely.
That's important because there's a use for the backbone. There's this nice backbone that nobody's using, essentially, because there's no applications.
Well,
And
that's...
it doesn't have to be connected to the internet at the access point.
Well,
at
so
the remote
from a
end.
commercial standpoint, from a
Yeah.
non-amateur use standpoint, that was originally the design.
Oh my goodness.
Well, think
Because
about...
D-Star was not.
Yeah, well, think about, but from a commercial standpoint, say I have a municipal network, right? And it could be totally firewalled off, air-gapped from the internet. I want to have multiple repeaters that I
There you
can
go.
talk to. I don't care about talking to somebody, 3 states over. I just care about my local
That was
network.
perfect.
So that was originally when what basically happened was when this came into amateur use. That's when the network started getting larger and larger and larger. Part of that too was because those master servers that I kind of alluded to, in Motorola's case, are very, very expensive. So if you're a municipal network, maybe it's worth you buying a C-Bridge for $50,000, $100,000, whatever for your local communication. If you're a guy who got a repeater off eBay, that's not something that you generally want to do. You'd much rather join somebody else's network so you can talk with them and use their existing server. So that the original use case was really you own all the repeaters, right? And they can talk to each other and link dynamically. Amateur use is what got into the super network, effectively. And last one, wide compatibility, right? This is a cheap Chinese radio. I can talk to somebody that uses the same over-the-air protocol, in his $1,000 Motorola mobile rig. From my perspective, as long as I'm talking up to the repeater and the repeater is doing its job, everything works great. So again, I've said DMR adoption is increasing at a pretty rapid rate. It's finally getting into that low-cost commoditization phase. It's a really good time to kind of look into it and see if it's something if you're interested in.
Questions. So you mentioned DMR-Mark, or is it Mark DMR? DMR
Dash Mark.
Plus, was it?
So yeah, DMR Mark, right?
Yeah.
That's the.
And then there's the third one, and then there's
sorry.
Brandmeister.
Right.
So whether it doesn't, are all these networks interconnected?
No.
Ah.
They
So
are
now
not
I-
interconnected, mainly because, again, DMR Mark uses that specific Motorola protocol.
Oh.
So there are some individual talk groups that some networks have managed to share, mainly DMR Plus and Brandmeister. I said before, DMR Mark tends to be very, very conservative. They have been very touchy about trying to interface with other networks in the past. And there's been a lot of, some people say, kind of political shakeup in the way they're organized. The impression I got is that's been improving, and I have noticed some pop up in that list that I think, if I have the, so I think these guys, the ones with the B, are actually linked to other networks now. My understanding, and again, take this with a big old grain of salt, because they were pretty resistant for a while, Brandmeister tends to link to everybody as much as it can. I've seen a couple people experimenting with using Ambi chips, decoding, and trying to cross-code over from even D-Star. The audio quality on those experiments has not been great from what I can tell, but there's definitely, again, Brandmeister tends to be the one that has the most experimentation going on in terms of linking to other networks.
But there's probably no repeaters in this area that are connected to that Brandmeister network, right?
That is my understanding, yeah. So when I access Brandmeister, I do it entirely via hotspot. What's up?
So, what would you recommend as a good book or website for further reading to review all the things you've just talked about?
So I actually have, Pat, a couple of recent links in here, and wow, that's a really awful color choice. So I'm going to put this up on the Reflector and post
Okay.
these. There was, the really big one is called Amateur Radio Guide to or Digital Mobile Radio. I think that one was pretty DMR mark specific. But in terms of going into a lot of concepts, color codes, those kind of things, has a lot of good information. I think there's some good info linked to from the K4USD network page, which is the one that K3UCP is a part of. And there's also there's a series of repeaters up in Toronto run by VA3XPR, and they posted this very short, what they call code of conduct, which really has a lot of those kind of tips on don't do this stuff, and here's why. Things like don't rag chew for long periods of time, it will flood the repeater. And it tends to do it in a really good kind of, this is the effect that these things can have, and this is why, you know, we try not to use those. There was also a presentation at Dayton, I want to say 1 or 2 years ago, by one of the operators of the DMR network, DMR Mark network. Now again, a lot of that was before Brandmeister came up, so there were a lot of kind of assumptions made back then that this was the way things were. But as a primer, it's pretty good.
So to get that ID, you have to go to the Mark-DMR,
Yeah,
and they will do it.
DMR-mark.org. I'm trying to.
And they do it for any network.
Yep.